Hi, everyone. My name is Sergey. I'm the zk researcher at L2Beat. And today I will be kind of using what we see in the L2 space and try to talk about what's going to happen in the Ethereum L1 itself. So we see that zk successfully scales L2s today. And the Ethereum Foundation wants to use it to scale L1. And in my talk, I will tell what's the plan and what are the challenges. Here is the more structured agenda. I will start talking about validity rollups. And a small note, I will try to say validity tag, proving tag, because I will not be using actually the zero knowledge property of these systems. But for the legacy reasons, people still often say zk, which is not fully correct. Yeah, so I will start with this, talking about state of the art. Next, I will go to the present. I will talk about the zkEVM proposal to bring zk to the execution layer of Ethereum. There is a proposal called Beam Chain that also tries to bring zk to the consensus layer. I will not be talking about that. And I will speak about some additional challenges. So let's start. Here is a general picture of the proving system that you have. This is a way, as probably many of you know, to attest to some computation. And in this mental picture, you always have a program that you are proving, a guest program. You have an entity that shows a prover, a verifier, some proving scheme. And the key feature of these systems is the asymmetry between prover and verifier. So here you can see, just to give you a taste of the scale of provers. So for linear, they need approximately 1 terabyte of memory for running the prover. Maybe a more modern example here you definitely cannot see. But these are the specs of a proving cluster that the Ethereum Foundation plans to get up and running. So the cost of the hardware it was estimated to be 250k euros back in February. The operation is another 100k per year. So this is, proving is a big, tough thing, which not just has some big capital costs, but also running operation cost. So the validity rollups is this technology that is quite well known, and the idea is that you take transactions, outsource them to L2, and to stick to our mental model of proving systems. So the guest program that you're proving is the state transition function of L2. This is your L2 client. The prover is the operator of L2, and the verifier is a smart contract on Ethereum, usually. And here's a picture that shows from our website that shows that this strategy of scaling was quite successful. So here you can see a blue line. These are the transactions processed on Ethereum. So on a good day, you will have maybe 30 transactions per second, or the user operations. And the purple line are the rollups. So to be fair, so most of this is zk rollups. Actually, most of this is one zk rollup. And if you want to know which one, feel free to visit our website. But you can see the systems on our website. And a couple of things that we currently see right now. I just want to give you a taste. So most of the projects that do have a functional proof system, these are the projects that we call stage 0, stage 1, or stage 2. So 23 out of 30 projects do use some form of proving systems. Interestingly, only around 13% of total value is secured with these proving systems, but this will probably change very soon, less than in a week, with Base making an upgrade. But interestingly enough, there is only one project currently that allows permissionless proving, so it allows anybody to submit a proof. And the rest of L2s, they have their own proving infrastructure, so in the end, malicious actors cannot even attempt to break the systems, and as a consequence, these systems are not really battle tested at the moment. So it would be fair to say that many of those teams have been working on the proven systems for years. They've done a lot of development work, and they've done a lot of effort on auditing, formal verification. Here are some names. You can also learn more on our website. And maybe a key feature of these systems, let's say, are these vulnerabilities. So here you can see one was found maybe 10 days ago in Jolt, proving something that's obviously not true. Earlier this year, L2 had to stop the operation because of the problems with the zkEVM protocol and so on. Bugs are being found. So this is the reality, that these bugs are being found pretty much every week, and L2s fix them all the time with emergency upgrades. They have to stop operation, they have to do these upgrades. So this is the general agreement, I would say, is that this tech is kind of not really mature to the standard that you can just put it out and hope that nothing bad will happen and no exploits will happen. So let me switch for a moment to speak about L1 now. When I say present, as I'm a researcher, so this is kind of the present of research and development. This is being actively worked on right now. And just as a reminder, again, I will be talking only about the execution layer of Ethereum. So let me remind you the current block production pipeline for Ethereum. It starts with validators auctioning off the rights to build blocks. So validators, the people who stake the ETH token, don't produce blocks themselves. These blocks are produced by just a handful of entities. Here on the chart, you can see, for example, around 50% of the blocks currently are built by Titan Builder. There are a couple more entities that build blocks, which together with Titan Builder build a good majority of all the blocks. And these block building entities, they are quite sophisticated operators. They run some non-trivial software. They run quite performant hardware. And when these blocks are produced, then the validators have to check that the built blocks are correct, transactions are fine. So they do it by re-execution, and these blocks also then propagate through the network. And this step of re-execution, the transaction by validators, is the current bottleneck on L1, preventing us from raising gas limit to higher and higher values. The reason is that these validators are expected to be running quite normal hardware, so some operators at home and so on. So the zkEVM is a proposal to basically solve this bottleneck that I just showed you. And the idea is conceptually exactly the same as the idea of validity rollups and L2s. The idea is that the validators will not re-execute the transactions, but they will just check some proofs of execution. And this should look somehow like this, the new pipeline. So again, validators auction of the rights, the builders build the blocks. And then there is this new entities called provers that now prove the blocks, produce zero-knowledge proofs of the correctness. And validators have to just verify these block proofs instead of re-executing them. And then the blocks are propagated through the network. So here you can see there was the old bottleneck with the validators. And now it's not a bottleneck anymore because verifying proofs is very fast, very efficient. But with this strategy of zkEVM, you introduce a new bottleneck, number 3, with the provers. So this will be quite an intensive step. And the whole idea of the strategy is that these big, beefy prover machines will be able to prove blocks faster than validators will be able to re-execute on their customer level hardware. So yeah, this is how it's supposed to be working. couple of words about implementation. So how you do this, you take an L1 execution client, like Geth or Nethermind. Optionally, you can re-execute it in a zk-friendly language. Rust seems to be a popular choice these days. But next, you want to compile this program, the execution program, into a zk-provable program called guest program. And then if you want to prove a block, you have to prepare the input into the prover, and this will aggregate all information like transactions, state access, info. And this is a big part of current research and development, actually. And then you prove all this information with a proof system. This is let's say, the most demanding step of the pipeline. So this strategy of zkEVM is being kind of promoted and pushed forward by a team around Justin Drake. And here I have a picture from DevConnect in November last year. On an ETH-Proofs event, he presented a demo where his client locally was doing exactly this. His local execution client was verifying the proofs that were generated for it in real time. So this already shows us that this is not, let's say, ambitious strategy, and this is something that is actually kind of realistic to do. So recently, Ethereum Foundation published this straw map, which is a proposal for a timeline. And I looked through it and I picked points that are relevant for this zkEVM timeline. Currently, we're in these first steps. The hardening of the tech, the zk clients and provers still has to do a lot of work. The security standards are being set up right now. And the next deliverable is supposed to be in Hegota. This is called EAP 8025. And these are optional proofs. So validators will be allowed to not re-execute blocks, but verify zero-knowledge proofs. I would say this part is not really contentious. Next, it's kind of up in the air. It could change many times over. But the next idea is to maybe optimize something on L1 for more efficient zk proving and eventually introduce mandatory proofs. So I would like to share some reasons why I think it's kind of realistic to expect that this timeline will work. And the first biggest reason, I would say, is the success of L2s. So we see that it is more performant to prove transactions than re-execute them. But then also there was a lot of development in the zk technology last year, and I think Jordi's talk earlier was a good illustration of this. So here in the last year, the speed of proving increased 5 times, and the cost dropped by approximately 15 times. These are very impressive numbers. This is from the blog post by ETH-Proofs, who track these things. So it's quite good numbers. So then there are also some teams that already operate these validator tools. They have experience in the operation thing, and then we also can kind of say that the outsourcing block building was a success to produce this quite intense and complicated pipelines. So all in all, I think there are some good reasons to be optimistic about this plan. But of course, there are still some challenges. And in my talk, I want to mention a couple of those that are unique for L1 and that L1 has to solve separately from the what L2s already have figured out. So here on this slide, you can see the diversity of Ethereum clients, consensus layer, execution layer. There are many different clients, and this is the reason why Ethereum has been operating for almost 11 years without going down. So this is very important for liveness of the system. And it also thought that this diversity should be the solution for potential bugs in the all proving infrastructure, so in all zk-related stuff. So it should be something like this. We need to implement 3 different guest programs, so 3 different zk clients, maybe repurpose the already existing ones. We need to implement 3 different proving systems. Then we pair them together. We have these 3 different proofs. All the proofs always must agree. If one disagrees, then kind of we can use the other 2 as a source of truth. But you can see that this is just a huge engineering coordination task. You basically have to implement the same thing 3 times, and this is yeah, a lot of work. And by the way, all tools have it easy. They don't diversify. They usually run just one guest program. They have just one proving system, and they don't need the same level of diversity that Ethereum expects. So the next challenge is the speed of proving. The issue here is that the validator wants to sign a block before propagating to the network. So, okay, there is a proposal for delayed execution, but realistically there is around, let's say, more or less 10 seconds to prove an Ethereum block. And this is not too much time. So there was a lot of progress with parallel GPU proving. I don't think if you can see the right part of my slide, but here approximately 91% of blocks can already be proven in under 10 seconds. This is the current data from ETH proofs, but still there is a way to go. And this is also the main idea. This GPU parallelization is the main idea for this proposed EF cluster packed with GPUs. But even with these hardware solutions, realistically, we should still see some optimizations for proving systems. They need to be sped up. It's an interesting question whether decentralized proving is feasible. I think Jordi in this presentation tried to make an argument that this could be done, and I would be happy to see this. But anyway, this is also a challenge. And for L2s, this real-time proving is not a concern. So what they do in practice is they publish a block to L1, and the proof arrives maybe minutes, maybe hours later. So they have this settlement time. But this is a completely different timeline, so they don't have to prove these blocks in real time. So the next challenge is very important for Ethereum coordination. This is the question of, okay, who will be producing these proofs? And this is, as I mentioned, has a big operational cost depending on the prover and so on. But let's say this is the range in which the prover costs are, so 100K to 1 million. And this is, for example, for one prover. If we have 3, you multiply this by 3. In the initial proposal of these optional proofs that is coming in Hegota, the provers are assumed to be altruistic, so this is really like a bootstrap version. But of course, long term, we will have to find economical solution to this. And the question is how we will pay for this proving. Will it be paid from block building MEV? Maybe transactions will have additional prover fees, how it's, for example, currently done in some L2s. Maybe we'll have additional ETH issuance. I don't know. We have to ask ourselves. And another related question is whether this will lead to some further centralization long term. So here it's a bit similar to block building, and I already showed you that block building is quite centralized. But I would argue proving is still a bit different, because with proving, if you cannot prove a block, then you're the whole blockchain is stuck, and for proving you need hardware. And even if all block builders go down now, validators will still be able to continue building blocks, maybe not this efficient, and not so well as block builders can do this. But anyway, this is another risk that we definitely should keep in mind. And of course, L2s don't have a question of who is proving. They're the ones operating the systems, and they're centralized. And the last problem I want to mention is that we see currently in L2s. The guest programs and provers are upgraded all the time, so you have upgrades and fixes. So we would need some sort of upgrade process around and versioning to avoid malicious upgrades. This is something we already have in the clients, but now we also will have this proving system additional layer of complexity. So this is just a coordination challenge. Just throwing a thought out there, maybe we can have some on-chain registry for programs and provers. And L2s, they obviously don't care too much about the auditability and transparency of the upgrades. They just do it, and then that's it. And just at L2Beat, we have an experience of tracking the upgrades for programs of these proving systems, for also provers. And this is actually not very transparent and not very easy to track. So this is something we should keep in mind for L1 as well. So that's it. That's the end of my presentation. If we have time for questions, I'll be happy to answer. Otherwise, feel free to catch me if you see me. Yeah. Thank you.